Picturing a battle between our solar system's biggest planet and a wandering black hole, it sounds like something straight out of a movie. But let's really dive into it, because this cosmic showdown isn't just for kicks. It reveals the delicate and maybe kind of fragile balance that keeps our entire solar system safe.
Okay, but before we shoot off to Jupiter, let's start things a little closer to home. Actually, let's bring it way, way closer, like right where you're sitting. Because believe it or not, the whole story of rogue black holes starts with a really strange and very personal question.
Yeah, I know. It sounds absolutely nuts, right? Like something you'd hear on a late night radio show. But just stick with me here for a second because the answer is, well, it's actually plausible. That's right. Some cosmologists think the universe is just filled with these ancient, microscopic black holes. I mean, we're talking about objects with the mass of a single bacteria, but squeezed into a space smaller than an atom. And they could be zipping through you, your walls, of the entire planet without ever leaving a trace. So yeah, if they're real, they're totally harmless. But, and this is a big but, they have some much, much bigger, meaner cousins.
And those are the ones we really need to talk about. These aren't harmless little relics from the Big Bang. No, these are the real ghosts of our galaxy. And the difference in scale here is just wow. It's staggering. So on one side, you've got these tiny, maybe they exist, primordial black holes. And on the other, you've got stellar mass black holes. These things are the real deal, the collapsed cores of massive stars, packing 3 to 10 times the mass of our sun into a ball just a few dozen kilometers across.
So, how does a black hole go rogue anyway? Well, picture this. A massive star dies in this colossal explosion, a supernova, right? But that explosion isn't always perfectly symmetrical. If it's lopsided, even a little bit, that newborn black hole gets what scientists call a natal kick. Basically, it gets launched across the galaxy like a silent, invisible cannonball untied to any star system. And get this, they're not even rare. Scientists figure there could be something like 100 million of these things just wandering around our Milky Way. They're a huge but completely invisible part of our galaxy's population. Okay, so if they're totally invisible, how in the world do you even look for them? Well, astronomers have this really clever trick called gravitational microlensing. A black hole gives off zero light, but its insane gravity warps the space around it. So when one of them happens to pass in front of a distant star, it acts like a cosmic magnifying glass, making that star's light get brighter for a little bit. And just like that, you can see something that's literally invisible. All right, so we've got 100 million invisible cannonballs flying around out there. What happens if one of them isn't just passing through? What if its path lines up with us? The destruction would start way before it even gets close to the main planets. First, it would smash through the Oort cloud, that giant shell of icy stuff at the very edge of our system, unleashing a deadly storm of comets right at the inner planets, including us. Then it would tear through the Kuiper belt, throwing Pluto and its neighbors into complete chaos. And as it swept past Uranus and Neptune, its gravity would literally start ripping their atmospheres right off. And the weapon as black hole wields? It's pure gravity. More specifically, something called tidal forces. See, it's not just a simple pull. The black hole yanks way harder on the side of a planet that's closer to it than the side that's farther away. This difference creates this incredible stretching force, a force so strong it can tear a whole world to pieces. And you know what? We can actually see this in action right in our own backyard. Those beautiful rings around Saturn, they're probably the leftovers of a moon that got a little too close for comfort and was just ripped to shreds by the planet's tidal forces. They're a silent monument to just how powerful gravity can be. Okay, the black hole has punched through the outer defenses, and now it has its sights set on the main event, the king of the planets, Jupiter. And let's be clear, Jupiter is an absolute beast. It's bigger than all the other planets combined. Its gravity is what keeps the whole system in check. It's basically our solar system's bodyguard. But in this fight, it doesn't stand a chance. The end would be fast and unbelievably violent. First, those tidal forces would peel away Jupiter's massive atmosphere, and that gas wouldn't just vanish. It gets sucked into this spinning, superheated disk of doom around the black hole. As the planet's core gets eaten, this disk would light up, unleashing a terrifying blast of high-energy radiation. And the craziest part? The whole thing would be over in just a few hours.
And that's when it happens. For the very first time, this invisible hunter finally shows itself. From Earth, we'd see a new, blindingly bright star in our sky, shining with the last remnants of Jupiter, shining with the light of its final, spectacular meal.
So, Jupiter's gone. The gravitational anchor of our entire solar system has just been obliterated. What does that mean for us, back here on our little blue marble? Well, the first thing to hit us would be that blast of radiation from Jupiter getting torn apart. Moving at the speed of light, it would slam into Earth in under an hour, a wave of X-rays and UV radiation that would be a direct, deadly threat to all life on the surface. But let's say we somehow survive that. Our long-term future is not looking good. You have to understand, for billions of years, Jupiter has been our cosmic shield. Its huge gravity has deflected countless comets and asteroids that would have otherwise hit us. It also keeps our orbit nice and stable, which gives us our regular climate. With Jupiter gone, that shield is just gone. The result? Absolute chaos. The nice, predictable clockwork orbits we rely on would be completely shattered. Earth, Mars, Venus, we could get flung into wild new orbits, causing crazy temperature swings, or even worse, get knocked onto a collision course with each other. Yeah, our solar system basically becomes a cosmic pinball machine, and we're one of the pinballs. Okay, I know. This is a terrifying thought, right? A silent, invisible killer coming out of the dark. But before you start boarding up your windows, let's take a deep breath and get real for a second. The simple truth is space is just huge. I mean, mind-bogglingly, ridiculously empty. So while there might be 100 million of these rogue black holes out there, the chances of one getting anywhere close to us are, for all intents and purposes, 0. Our planet's been here for 4.5 billion years without a problem. Bottom line, we're safe. And you want to know the really cool part? We aren't just sitting around crossing our fingers. We are actively hunting for these things. NASA's got this new telescope, the Nancy Grace Roman Space Telescope, launching soon, and it's going to use that same microlensing trick to find these exact kinds of rogue black holes. We're literally shining a light into the dark to see what's out there. And that kind of leaves us with one final thought. Sure, this whole thing shows us just how lucky we are in our stable little corner of the universe. But it also shows us that we're not just passive observers anymore. We're out there actively searching the great unknown. So maybe the real question isn't what's hiding in the dark that might find us, but what incredible secrets are out there just waiting for us to find them.